The second frame, we are talking about this frame. So we just examined what circuit variables in circuits, what are they? Now we are going to go a bit in details for the circuit variables. These variables there are two main groups. Fundamental circuit variables, these are currents and voltages. Currents are unit of it, amps, and voltage of its unit is volts. Other variables, power and energy. Power unit is watts and energy unit joules. Now we will be examining now these variables separately. So one video for the fundamental circuit variables and the second video for the other variables. So let's come to these fundamental variables now. Okay. So the origin of these variables is the electric charge. Electric charge is related with electron within atom. We know atom has got two parts, a nucleus and electron turning around a nucleus. So this electron has got a charge, electric charge. It is a negative charge. Positive charge is in the nucleus. So negative charge electron has got charge, that amount of charge, 1.6022 10 to the power minus 19, 10 to the power minus 19 coulomb. This is a unit. So the fundamental variables that we said, that current and voltage, is based on this variable. So if the charge is moving from one conductor from one point to another, that means electrons are moving or charge is moving, so that means they are introducing the current. If the electric charges are separated from each other, and then this introduces a voltage. So separated electric charge is voltage, flow current, electric charge flow is current. So what is the voltage then? We've got to define the voltage in terms of charge, and we've got to define the current in terms of charge once again. So the basic physical quantity is charge. So V is equal to dV. W here represents the energy. So when the separated charges are changed, difference of the charge will affect the energy. So this derivative gives us the voltage. Voltage in volts in terms of units. Q is coulomb in terms of charge, and time unit is seconds in this equation, in this derivative. So this seems a bit complex. So we can say that operational definition, it says voltage is what voltmeter measures. There is a voltmeter. This is an equipment. Whatever this equipment measures, we might think this is a voltage. So we could use this operational definition in circuit theory without going in details in physics. So let's come to the current. Current is the derivative of charge change in terms of time. When time difference introduces charge difference, the ratio of those two gives I, or in other terms, derivative of Q with respect to T gives the current. So current unit is amp, charge unit coulomb, and the time unit seconds. So similarly, the operational definition of the current is what a meter measures. There's an equipment which is called a meter, that a meter measures the current. In practice, there is just one equipment. It is called multimeter. That multimeter measures voltages and the amperes as well. So one multimeter at the same time a voltmeter and a meter. So once you come to that operational definitions, though, we've got how we are going to measure it. So the next step is to examine those. So let's come to operational voltage definition. We have done it. What a voltmeter measures, how we are going to measure the voltage. Now in here we've got an element A, and this element voltage, how we are going to measure it. We are going to measure it by connecting our voltmeter, which is this, to this element. So this element has got two terminals, one of them here, the other one is this terminal. So we are connecting, voltmeter has got two terminals as well. So we are going to connect one of the terminal of our voltmeter to the one of the terminal of element A, the other terminal to the other terminal of the element A. So then this voltmeter measures and gives a real number to us. That real number is the voltage of this element. But these voltmeters, you can see in this video as well, has got two different color terminals. One of them is red, the other one is black. So if you interchange this voltmeter's terminal, if you replace the red terminal with the black one and black one with the red one, whatever you measure with this voltmeter is going to have the same absolute value but different sign. Assume that if the first measurement is 5 volts, the second one is minus 5 volts. So the result is this: if different people measures this element voltage, some of them say minus 5 volts, the other plus 5 volts. So we've got to introduce now a reference concept in order to give the same voltage value which is measured by different people. So how we are going to do it? So we are going to choose a voltage reference for the element A. So if we choose the plus terminal of A is the left terminal, this terminal, and if we choose the other terminal as minus, so that means we put a voltage reference to this element. And then if we connect the red terminal to the plus terminal of our element and the black terminal to the minus terminal of our element A, whatever measured here is going to be the same for different people measures. What I mean is this: if the voltage reference is the same for the given element A, then the connection of voltmeter to this element A with proper way to the references, then all people are going to measure the same value. So everybody measures the same voltage value if they choose the same voltage reference. So there is a video here, you could watch it, how we are measuring it. So conclusion, we need a voltage reference for an element in order to measure its voltage. So similarly, when you come to this current or a meter is the equipment name to measure the current, is going to be a bit different. Since we are going to measure the current, that means the electrons passing through the element. So we're going to measure this element current, that red one. how we're going to do it, it has got two terminals, this element. So one of the terminal is going to be a wire here. Remove that wire and replace this wire with our emitter. So this is what is done here. So this connection is called serial connection. Why we are doing so? Because the electrons passing through this element A will also be passing through this emitter. So we are going to measure these electrons. Therefore, we've got to connect them in serial. But once again, if you do this connection, this emitter gives a real number. But if we interchange these emitters terminals from black to white, black to red, red to black, we are going to end up with a same absolute value real number with a negative sign in front of it. So that means some people is going to measure, let's say, minus 2 amp, some people are going to measure plus 2 amps. So in order to give the one result only, we've got to choose this time a current reference for an element. So this is the current reference for this element. So we said our equipment has got two terminals, plus terminals, minus terminals, or in other words, plus is the red terminal and the minus is the black terminal. So we assume that the current reference of this emitter is from plus to negative. So the direction of the current reference of our emitter is going to be the same direction as the chosen element current reference, which is this. This should be in the same direction because we would like to measure the current of this element for this reference with this equipment. So both of them references should be the same. Or you might call this a proper connection of emitter serial to an element A. So everybody measures the same current value if they choose the same current reference. So that means by choosing this current reference, we will end up the same result. So let's see what we have done here. Go to the home. So we mentioned about the variables and their relation with the circuit, and then we said there are two basic variables, current and voltage, and what they are and how we measure this current and voltages in here we explained. The next step, we will be examining the other variables, which are power and energy.